Welcome to the Julia day of this course. We're starting with why, and I think the best place to find why Julia is to start with why it was created. Because when I read this blog post that announced Julia to the world, I felt, oh, this is language for me, so this is good motivation. So, quoting that blog post, in short, because we are greedy. Then the creators go on and mention many languages that they enjoy. Languages such as Matlab and R and Python are mentioned, but also C and other languages. And they say, we love all of these languages. They are wonderful and powerful. For the work we do, scientific computing, machine learning, data mining, large-scale linear algebra, distributed and parallel computing, each one is perfect for some aspects of the work and terrible for others. Each one is a trade-off. We are greedy, we want more. And when greedy programmers want more, they have a tendency to create it. And no language can be everything for everyone. But Julia was created to get as close as possible for a certain set of users. And if the work you do falls in the categories mentioned, as HPC work generally does, the target audience for this language includes you. So, what are we going to learn today? We're going to learn when Julia is and isn't the right tool. We're going to learn how to load the cluster modules providing Julia. We're going to learn how to use Julia environments and why. Get familiar with PKG in installing and managing Julia packages. How to write batch scripts for running non-interactive Julia jobs. And how to work interactively with Julia on the clusters. Then on Friday, later in this course, we'll explore some of the different Julia parallelization tools. We'll learn about running CUDA with Julia and run some machine learning job in Julia. What is not covered in this course is to learn Julia coding skills. This is provided by many other courses on the internet. And we're not going to learn anything about running Julia on other clusters or systems, even though many clusters are probably quite similar. So let's start with when Julia isn't the right tool. So these are my main reasons to choose Julia. The strengths of Julia are based on flexibility. More so than forcing either your code or your workflow into anything, it enables you to choose the right way to write or the right way to work for the task at hand. The special compilation model of Julia enables interactive use and development without the drawbacks of interpreted languages. You can write a function and use that function and it will actually be compiled and run fast. But it also enables compiling whenever it makes most sense to do the compilation. It has a special type system that is hierarchical and very deep, so that types can be defined as precisely or as loosely as makes sense for each situation. So if you're adding two numbers, the add function, you add two numbers. It doesn't need to care what the numbers are. But if you do need to care, you can be as precise as these are two 8-bit integers. This hierarchical type system, along with multiple dispatch and the special compilation model, enables this great flexibility. But it also enables great composability, meaning different sets of Julia code can work very well with each other, even if they were not intentionally written to work with specifically each other. Julia is also built for numerical computing, but it also works well for general tasks. There are web development packages and such that are very useful and well done in Julia. Julia also has a built-in powerful package management that we will see later on in this course. And finally, the built-in or integrated documentation tools are good enough that many Julia packages have relatively good documentation. Julia is not as large or popular as Python, so there isn't as a wide a user base and as large knowledge base on the internet, but you can pretty much always easily find the information you need. So, and in addition to the strengths of the core language, a few standout packages that you may want to make use of are Pluto, which are reproducible, Gitable, and extraordinarily interactive programming notebooks. This is one reason to go with Julia, because it has Pluto. There is also a machine learning stack called Flux, which is based on differentiable programming, which Julia, with its type system and so, does especially well. And there is a package called differential equations, which is also especially state of the art. And that package is a component of a large SciML toolkit for machine learning. And there is a package called JUMP, which is a modeling language and toolkit for mathematical optimization. Those are some of the reasons to choose Julia. As for reasons to choose something else, an interpreted language, such as R or Matlab, will execute your instructions immediately without any compilation step. So if your code changes and recompiles a lot in relation to the time spent running the code and the computations, this will give you a better interactive experience than Julia. This will actually save CPU time in extreme cases. For really large projects, the structure and consistency enforced by a more rigid language such as Java can be an important benefit. As we said before, Julia is very flexible and can be written in different ways depending on the task. This, in a really large project where many people work on many different parts, can be not a good idea. As always, it may be faster to use a tool that you already know well than to use a tool that you haven't learned yet. And finally, there are some cases where existing tools are best used from their own environments. If you have packages that have graphical tools and graphical interface, in general, you should stick to the environment that they were built in. However, if it's pure code packages, libraries, the Julia solutions for using packages from other languages, such as R packages, Python, Matlab, Fortran, C, they are very useful and work very well. So that's it for this introduction.